So I would like to welcome everyone to the Seattle Software Crafter Meetup. We are a group of individuals that like to get together once a month and talk about ways that we can improve our craft and how we can get better at what we do. We try not to focus on technology-specific things. Instead, what we try to really focus on is ways to write code better agnostically across whatever language or techniques or patterns that we have that allow us to write better code faster or more effectively. And this is something that we've focused on for many years. We've had a number of different sponsors that have helped us right now. Currently, Industrial Logic, my employer, is also sponsoring us by the use of their Zoom channel. We look for people in the community and in not only within our community, but within other greater communities that do this to come speak to us. We are homegrown. We're getting towards the end of the year, and November and December, we traditionally change up when the talk is. It's not the fourth Thursday of the month because in the US, the fourth Thursday in November and December tend to be problematic. The last couple of years, we've been doing it on the third Thursday of the month, and we will continue that. And we'll continue the tradition. Paige will be doing December. I'll be doing November, talking about things there. And so we'll keep doing that. Beginning of the year, hopefully we'll be kicked off by Llewellyn Falco. And what we do is we're here to talk about how we can get better. Paul, who's been a long member of the Seattle Crafter Group, is someone who I met, I think it was at the Agile Alliance Technical Conference way back when, and then also at the Deliver Agile conferences, which are the Agile Alliance technical conferences as well. He and I got to know each other through those conferences. He came and he saw, I met him in LA at the Polyglot meetup down there. He's very active with Agile SoCal and is, in my mind, a consummate crafter. He's always giving talks on a number of different interesting topics. The most recent one that I saw him on was the Mob Mentality Show. And it's a good talk. And the Mob Mentality folks who were here last month, always good to listen to, always very fun. Today, Paul's going to be talking about Santa Claus metrics, which is wonderful. I love it. So, Paul, go ahead, take over. All yours.
All right. Thank you, Steve. And this is my first iteration of this talk, so I asked Steve and Paige to field the chat for me, but I'm probably going to wait to take any conversation questions at the end. But we're going to see how this goes. I suspect I've got a lot more content than I think I have time for, but we'll see how it works out here. So as I get everything set up, let me get my Zoom windows in the right place I expect them to be. I did a version of this talk in person a few years ago at an open space, and it was received okay, but the crowd response was mostly like, well, you told us there's no Santa Claus, now what? And I'm like, well, isn't that good enough, But I'll try and give you some remedies to this situation here. But when I thought about this, I was really thinking about my first encounters with code coverage and what it felt like when I really pulled back the covers, on code coverage. And if I ask this room, I see some gray hairs, I see some beards, and I ask, who believes in Santa Claus? Everybody's going to go, no, I don't believe in Santa Claus. And yet, when I think about the amount of effort and, impact that Santa Claus still has to this day, it's like we get presents out of it. We get my family was big on stockings with the candy and the toys and little knickknacks in there. More than anything, it's probably the precious memories that we're building up for our kids. And in fact, our government is in on this scam. Defense.gov has a website for NORAD tracking. I mean, NORAD is still devoting manpower to this thing, that there's actually people tracking Santa Claus on Christmas Eve and where he's at. And when I thought about it, it's like we really perpetuate this myth to make our kids happy. And at some point, I can remember waking up one night, walking down the stairs on Christmas Eve and seeing my dad setting up a train set. And it's like, wait a second, what's this about? And then talking about it with some other kids in school, it's like, oh, okay, there's no Santa Claus. But when I talk to companies that are trying to be more effective at software development and get really good at their test coverage, I don't know that everybody has kind of caught on that there isn't 100% code coverage. And when I started to put this together, I've kind of realized that there's no Santa Claus, there's no 100% coverage for a decade plus now. But I still find these things like, the industry standard for code coverage is about 80%. Okay. Google, 75 is commendable and 90 is exemplary. And it's like they're just throwing numbers out there and they're not really putting any context to it. Atlassian, this harbinger of all sorts of things, generally accepted that 80% coverage is a good goal to aim for. It's like they're putting numbers in front of us and saying that you've got to get there. And if you don't get there, you're misbehaving. You're going to get a lump of coal. And so we've got all this tooling around it. We've got this, notion of whether that's the right thing or not. There's tooling out there that like Azure DevOps has a target set 60 here, but the default is 70%. Like 70%, if you're not achieving 70%, your build fails. And of course, I looked at, oops, forgot this one. So my feeling is that we perpetuate 100% code coverage to make managers happy. The managers don't know any better. They don't know that there's no Santa Claus, but they know that 100 is a good number to strive for. And if we can't make 100, well, then maybe 70 or 80 or 90 is probably okay. And then, of course, the Defense Department actually has a whole paper on this. There's a 45-page paper on, DevSecOps fundamentals, test coverage reporting tools, encouraged to establish a high but reasonable threshold for code test coverage, and reporting of that coverage is vital. So it's like everybody's saying that, yeah, absolutely, 100% code coverage if you can do it, 70, 80 if you can't. So along comes my manager who's been doing some of this research, maybe went to an executive retreat, and he says, I'm going to have you go ahead and increase coverage to 80%. And what does that mean to me? Well, all of a sudden, instead of actually working on features and functionality that solves my business user needs, I'm going to have to start making the manager happy, because this is probably going to reflect on my review. This is probably going to impact my bonus. So let's take a look at what it's actually going to take to get to 80% coverage here. Anybody familiar with the Gilded Rose kata? Anybody seen this before? So I won't get into too much detail, but it's a piece of legacy code, doesn't have any coverage. My manager has told me that I need to start improving the coverage on this piece of code. And when I sit down and think about what this code entails, I start thinking about what the code's actually doing. The Gilded Rose is a kata where we've got an inventory for a store, and the store has all sorts of different things inside of it. The store has items of different types, normal items, special items, legendary items, and each item has an attribute associated with it. They've got a sell-in value, which tells when the item needs to be sold or it, kind of goes bad. And then they've got a quality value associated with it. But there's some funky rules around this. Some items decrease each day in quality. Some things like cheese, some cheeses actually get better with age. So the age actually, or the quality actually goes up as we do that. Legendary item, being a special magical item, doesn't decrease in sell-in or quality. And then there's these things called backstage passes, where the closer the concert gets, the more valuable they are. But as soon as the concert passes, they're worthless. And so anybody that's attended a conference or a concert this past year has probably seen some of this stuff at play, even just for the regular tickets. And so when I think about this list of things and some of the combinations there, I start coming up with a pretty decent list of tests that I need to write to get 100% coverage. I could also look at it in terms of just the mechanical aspects of this code. There's about 50 lines of code. There's 16 if statements in there. There's a 19 cyclomatic complexity, which is kind of the number of paths through the code. So I would guess, mid to high teens is probably the number of tests I'm going to need to get my 100% coverage of this code. And being a longtime extreme programming person, I actually make a list of my tests, usually on paper in my IDE, but I'm going to do it here in Keynote for y'all. And I just start listing out what are some of the different test cases that I'm going to have to cover. What are some of the behaviors of this system that we're going to deal with? This is, I didn't even count, but this looks like about a dozen different tests. It's not all of them, but I think this is a pretty good start of what we're going to have to do. And so let's see where we're at. We're going to do a little bit of demo here. It's funny to me, Steve's talking about Seattle crafters. I don't remember really ever seeing much code or tooling in here, but I'm going to dive into the code and tooling because it does make a big difference on what we're talking about. So I've got a version of the Gilded Rose in Java here. I've got a few tests in place, but they're disabled right now. I wanted to show you all that when I run this code with coverage, oops, got to do it up here. Got to do it right here. When I run this code with coverage, I just wanted to show you that we've got zeros. So the Gilded Rose class that we're testing, 0 class coverage, 0 method coverage, 0 line coverage. So let's start doing some things. And rather than writing code, because my typing is just horrendous these days, I just have some tests in place. I've got a test here for what we talked about. Cheese, the quality increases even after the sell-in date. So I've got a little helper method that creates an item of cheese type. It's past its sell-in date. It's got a quality of 20. When I call that update quality method, which is my triggering activity, I expect that quality to increase by twice as much. And I just have a message printed out there. Got another test here for Backstage Pass. The quality drops to 0 when the concert passes, because again, Backstage Pass, it's got a quality of 40. When that concert happens, the quality drops to 0. So, exactly what we expect the system to do. And then just another one, just to show a different item type for any type of item out there. I just call them generic items. The quality decreases twice as fast after the sell-in date. So I've got a sell-in date of 0 here, a quality of 10. When I trigger that activity, the quality drops twice as fast. So it goes from 10 to 8 instead of from 10 to 9. So just wanted to get some tests in place just to show you what's happening there. Let's run the test, make sure everything's passing. So 3 tests pass, quick feedback. But now I'm kind of just wanting to gauge how far along do I think I am with my code coverage. I've done 3 of around the 20 tests. So mentally I'm saying, 15, 20% coverage, but let's check it out. Running my code coverage here, and I am at 100% class coverage, 100% method coverage, and 100% line coverage. And so I see some cocked heads, and I'm telling you, there's no Santa Claus. This is true. I have achieved 100% line coverage at this point with just 3 tests and the Gilded Rose code. There's nothing magic here. Yeah, exactly. I'm done. My manager sees 100. I feel happy. I've hit that target. I got other things on my plate, so I'm just going to get back to work. So let's see what's actually going on here. Merry Christmas. We've got our presents, we've got our memories. Let's go on to something else. What's really happening here is I came up with some language here where I talk about intentional coverage versus incidental coverage. And this is really what's happening under the hood. The intentional coverage is code that is absolutely required to verify the behaviors under test. That is the code that if I were to change it, a test is going to detect that breakage and report back to me that something's going wrong, that code is actually covered in the way we traditionally think about coverage. But what's happening a lot of times when we're not really paying attention to how the tests are interacting with the code is we're getting this. Code that happens to be executed, but it's not verified by the test. It's just executed. It's just run. And the tooling doesn't know or care about the difference between the two. And in the example that I just showed in the Gilded Rose case, with those 3 tests, I get coverage for every line. But most of it is incidental coverage. If I look at the intentional coverage, the yellow lines here aren't actually being verified by a test. And in fact, I can delete about half of the code and the tests still pass. That I think if you're not really paying attention, you may be getting high coverage, but you're not really verifying behavior. You're just executing lines of code, and executing lines of code is all that coverage percentages care about. And so I'm sure some of you are a little bit more advanced in your Santa awareness. You're probably thinking along back of mind, coverage is an overly broad generic term. And yes, I agree. It's kind of like some of the other language that we use around our development teams. We just use this vague term that is overly broad. Mock objects comes to mind. Mocks is a very specific subtype of a test double, but we all say mocks just to cover the bases there. Going to Wikipedia, there's actually different coverage type out there. And that's what I'm going to dig into next, that this is the more important stuff to be aware of if you're trying to target coverage metrics. But as we'll see further along that, most of the tooling doesn't even get to this level. The language inside of Wikipedia talks about things like functions, statements, edge, branches, and conditions. We saw in IntelliJ, they talked about line coverage. They talked about method coverage. They talked about class coverage. So right off the bat, there's a bunch of different wording that goes around this. And if you're not being precise about it, you're probably not really telling the whole story. That when you do start talking about these numbers, you need to be precise. You can't just say 100% because somebody's going to interpret that statement or line coverage and it's not really the right thing. Apologies for no Christmas material here. I found a holiday sweater for Princess Bride to keep us on target here. So let's take a look at an example. And again, I think this came from the Wikipedia page. They just show a simple method here. The method takes a couple of parameters. If the parameters are both positive, it returns the X value. If either of the parameters is 0 or negative, it returns the Y value. So it's just kind of a weird maximum kind of thing going on here. But I want to show you what's happening for the different coverage types when we explore this simple method here. So with class coverage, as long as I call anything in the class, I get that class covered. I don't use this one a whole lot. I may use it on a legacy system just to determine if there's pockets of dead code, because we still do see systems out there where there's just code that's been carried along for a long time and it just got refactored out of existence, but nobody bothered to delete it. So I do look for that. But I don't really come across this one much when I'm doing like unit testing or TDD. Method coverage is kind of similar. As long as I call that method with any number of parameters, I'm going to get 100% method coverage. Doesn't really matter what happens inside of the method, just as long as it's called, you get the coverage out of it. The line and the branch are where it gets more interesting. So let's look at line coverage. Calling that method with 0, 0, I get method coverage of lines 2, or line coverage of lines 2, 3, 6, and 8. I don't get coverage of line 4. I would have to call foo with 1, 1, or some positive numbers to get coverage of line 4 there. And that's most of what the reporting is telling us, that, we got line coverage or not. But the more interesting aspect, and what I really look to when I'm doing like paying attention to the coverage numbers, is branch coverage. So when I call this method with 0, 0, branch coverage tells me this, that in most of the languages I deal with, if statements, Boolean expressions, they're going to short circuit if any portion of it evaluates to false. So here, X of 0, X is not greater than 0, it doesn't even execute this part of the line. And that's where we get some of those conflated numbers, that in line coverage, 100% covered. In branch coverage, 50% covered. And so now I've got to start passing in more values. If I pass in 1, 0, that evaluates true, this evaluates false, still don't execute that line, but now I've got branch coverage here. And when I pass in like 1, 1, I finally get that line 4 covered. And so that's really the important thing, probably the biggest thing to take away from today, is branch coverage is the more impressive and important number to pay attention to. Sadly, most of the tooling isn't there yet, and we're going to take a look at that next. So in the example that I just showed, 100% line coverage, we'll take a look at what the branch coverage is, and we're going to take a look at the things specific to JetBrains here. I think I may have skipped a slide, but that's okay. You can see out of the box, I don't even see branch coverage here. When I came back to this to try and figure out how to set this all up again, I went to settings. I looked for coverage here because I wanted to turn on branch coverage. Something about line coverage coloring. Something about, what else was here? There was build coverage that had all these radio buttons and a checkbox. And there was nothing about branch coverage here. So dead end, false start. Let's actually go to the other thing. We had to go and set up a configuration. Last time I had done this talk, I got a configuration by default. This time I actually had to set up a configuration. They changed the UI on me. And now I had to remember that, oh, there's this weird little modify options thing here. And it's got code coverage down here. And now they call it enable branch coverage instead of tracing, but that's good. So I did that. And once I do that, now when I run coverage, I actually get branch coverage. I don't know why JetBrains doesn't have that turned on by default. I've heard that it's slower, but it's not that much slower in every case that I've run it against. But now we can see with 100% line coverage, we've only got like 2/3 branch coverage. And in fact, if I go over to Gilded Rose, one of the nice things about some of the IDEs, the yellow coloring indicates partially covered lines, green indicates fully covered. And in fact, I can go to like this one and click on the gutter here and see, it was called true once and false zero. So yes, with those 3 tests, I didn't really exercise this code that much, but it was called with an item of quality greater than 0, but never called with an item of quality of 0 or less than 0. And so with some of this tooling, using the coverage information, really, really helpful, super valuable. Getting the actual numbers out of it, kind of less so. And since I only have 3 tests, I think most of these are going to be ones. Don't feel bad if some of this information, yeah, you can actually absolutely change the coloring there. And in fact, I changed it for the talk because when I did this originally, they've muted the colors a lot and they don't really show up well remotely. So I made them a little bit brighter. But if this branch stuff is new to you and it feels a little bit awkward, don't feel bad. When I set this up earlier this week, it took me an hour to get to what I just demoed for you. The first thing I did is I did that false start. I looked at that, I went to the settings for coverage and it's not under settings for coverage. Then I was like, oh yeah, there's this configuration stuff. And oh, JetBrains has released a brand new UI and I've got to set up a configuration. I've got to figure out what to pick in that dropdown, what to pick in that dropdown, what to pick in that dropdown. Do I need to type anything there? So I looked at their documentation and their documentation documents the old UI. It doesn't even document this stuff or that language here. So that's where that tracing thing came about. When I gave this talk earlier, it's like branching is tracing. Just trust me, that's what they call it. But now they've actually called it branching over here. And so I got this to this point. I hit OK, I ran coverage, and I got this. Internal error occurred. JUnit vintage. What? Huh? What? So Googling again. That's caused by a bug in version of JUnit 5 that you're using. It's been fixed in 5.6.3. So, of course, I'm using 5.6.2 in the implementation of Gradle that I happened to pull for this exercise. I made the change to 5.10 because that was the latest and greatest, ran it again, got the error again. And it's like, oh, yeah, there's this tiny ass little elephant here with a couple of recycle things. You got to do that when you make a Gradle change in order for the Gradle changes to be updated. And it's like, I happen to get through this in an hour because I live in Java mostly. And, people coming new to this, you're going to be picking and choosing from the internet all this information. And good luck if you can figure it out on your own. It's much better to pair or mob with somebody who's been through this, because I can point you to this in like 5 minutes and save you that hour. But these are the kind of things that we encounter all the time as crafters. We've got pretty powerful tooling, but we don't really do ourselves service when we try to document how that tooling works. Oh, yeah, that little tiny ass elephant. So I just showed you some of the branch coverage there. I'm going to switch to a different project now. I've got a project set up with what I thought was 100% coverage. It's actually got, not mutations, it's this one here. It's got 23 tests. Kill some of this stuff here. It's got 100% line coverage right now, but it's got all the different categories of tests. The 3 that I mentioned earlier, I've got parameterized tests in here. The non-legendary items, just make sure the sell-in date decreases, make sure that the sell-in date can be negative, all this sort of stuff. When I first encountered this idea, I sat down with a person I was co-teaching with, and we said, how many tests do you actually need to actually cover Gilded Rose? And so we came up with these 23 tests. If I run this without the branch coverage, 23 tests, really quick feedback. Let's go ahead and change our configuration again. Now that I know where to look, I can pretty much do it by muscle memory. And now let's run our coverage here. And yeah, taking a little bit longer, but not that bad. But now I can see I've got 100% branch coverage. And in fact, with the different types of testing that I've got, when I click on the gutter here, I'll see things like 24 times this piece of code was called, true 20 times, false 4 times. So you can see that I'm starting to get pretty good coverage. 20 of those times, it just decreases the cell-in. So when I think about how much testing is enough, how much is too much, this is some of the information that I use. 20 seems like a lot. I could probably parse that back, but some of the behavior just happens to incidentally execute this code. Again, the test is performing a more targeted behavior check down here, but it just happens to be executing some code up here. So the item class, I saw the comment in there. The item class, I think, has a print string or something, a toString method. It's just never called, and the item class is actually pretty tiny. So I don't know why it's calling it 100% branch coverage, because this one is actually nice. There is no cyclomatic complexity. It's just straight line code. Every line of code is executed if the method is called. But yeah, I'll have to dig into that more to see what's actually going on there. So anybody doing TDD? Anybody got 100% or 80% coverage with your TDD? So one of these is 100% TDD. One of these is the 3 tests. Which is which? You can't tell. The tooling can't tell the difference. On its own, that coverage percentage, even with the branch coverage, even doing TDD, it's possible to get into pockets of incidentally covered code and not know what's going on there. So I don't have a good answer to this one just yet. I do feel more confident personally when I've been unit testing and doing test-driven development that the number means something, but that's not most of the code that I deal with. I deal with a lot of legacy code where we have to come in and retrofit tests and then did we do the right thing? So some of you may be thinking, well, let's just write a lot more tests. And I'll show an example where that may not be the approach that's going to give you the 100%, 100%, 100%, kind of the done, done, done that you think it will. I'll do a quick demo of approval tests. I like approval tests for the combinations. I like approval tests for dealing with legacy code. I haven't really used it a lot outside of that, but what I'm about to demo is with the approval tests, combinations approvals, I can call that one method update quality and pass in a lot of different data. Effectively, what it's doing is it's taking these item names, these sell-in values, and these quality types, and just making a permutation for each of them. So literally it's going to do foo -10, foo -11, foo -15. It's just going to generate a test case for all of those, generating a lot of test cases. So let's take a look at that. Whoops. So let's go back over here. I've got an approval test set up here. Let me close that, just get some real estate here. Real quickly, for those who haven't seen it, I've got a commented version of this. The verify call for the approvals here is going to just make sure that this update quality method and whatever it generates out of this, that those strings match. So it's basically doing string checking. Before I run the test, what I do is I run the test to characterize what's going on there and I capture the results there. So that's a single item. I think it's this one. Yeah, so when I ran this earlier, I've got 264 different test cases that it's going to run. So it's just going to try all these different things. You can see aged brie. It's got, gosh, probably 60, 80 different versions of aged brie tests there. So let's see what happens there. And do I feel more confident when I run this particular test? And when I see code coverage, whoops, not running that one. Muscle memory, Control R. I just use Control R to hit my test. That runs the last test. And the approval test wasn't the last test. So that's what happened there. So it ran it. Let's run it with coverage now. Now that I've got that teed up here. Replace my active suite, so replace that 23. Looks like I've got that set up for line coverage. I don't have a configuration for approval, so I'm not even going to mess with that because this is live. All sorts of things can go wrong. But trust me that we do have the same level of branch coverage. But I know this problem pretty well. I've got 264 test cases effectively running against this, but I know that it's not 100% behavior coverage, because if I come in here and I change this to a 1, so I've changed the for loop, I've fundamentally changed the for loop, all those 264 test cases still pass because I'm testing one item at a time. I never once in those 264 test 2 items at the store at the same time. So if I don't understand the behavior of the system, there is a possibility I'm going to miss really important behaviors of the system in my tests. So Java, again, I kind of been in Java for 20 plus years. It's kind of what I live and think. This holds true in most other languages, and that's about where we're head to head next. Santa Claus is not just an American thing. This is like the Dead Moroz, I think. It's the Father Christmas, or Grandfather Frost. I actually like that name. This is a foreign version, so another language of code coverage we're about to see here. I use the JetBrains tooling quite a bit, so I naturally jumped over to Rider to see what was going on there. Straight off the bat, total statements. You know, I don't know why they can't spell it out. Why do they have to say uncovered total statements? I'm kind of whole other rant. Just tell me statements. But looking at it, it actually shows me update quality has 69 total statements. And when I think about the code, I mentioned it's only about 50 lines of code. So 69, that sounds like branch coverage, right? And that's more than the lines of code that we have. But what is that actually? Let's jump over there and see what's going on there. So let's jump over to Rider. I've got my 3 tests again. I've got them all in place. And I think on this one, I don't remember the Rider muscle memory as well. So let's just do that and run. Yielded rows update quality is line coverage. So that's a bummer, right? Because, you know, I don't know why it says there's 69 statements when, you know, it's showing me green for everything. Can't remember. Yeah, this shows me 2 tests pass, click to see the tests. So I can dig into it, but it's not showing me any yellow. So again, I don't remember how to turn on branch coverage in Rider. So let me jump back to the deck here to see how that works. And oh, yeah. April of 2010. I suggest you include branch coverage along with the line coverage that you provide. We are often required for branch coverage by our customers. This feature is already available for .NET by the InCover tool. So, okay, you know, they're aware of it. Somebody from JetBrains actually says, hi, Omer, branch coverage is already on our roadmap. It's planned after the 1.0 release. So again, this is like 14 years ago. And the story goes on. Oops. 2013, thank you for the active feedback and for the interest to the product. According to the current plan, branch coverage is scheduled for 2014. So now we're about a decade in the past. 2018, unfortunately, we still can't implement this feature due to the lack of resources, but it's not forgotten. You know, we didn't forget about it. 2022, dear all. So Ruslan, you know, bless you that you've been able to stay at the same company for 12 years. Thank you for your patience and for the active feedback. Branch coverage is getting back to the team's roadmap. But the team is going to start corresponding groundwork, et cetera, et cetera. And then literally last month, August life check ping, and one of the thumbs up is Ruslan. So there is no branch coverage native to Rider. And yet it's like the most important thing out of this whole coverage percentage talk that we're having here. I tried to show you some other tooling. I time boxed myself to an hour. I downloaded VS Code. It didn't support C# solutions natively, so I had to install and configure stuff. I wasn't able to run unit tests, and I didn't even get to the point of getting coverage running. And, you know, I'm a seasoned developer, and I kind of know what to expect. I couldn't do this in an hour. So instead, I downloaded Visual Studio. Free version runs my unit tests great. doesn't do code coverage out of the box. So I started getting into installing packages to collect and report coverage, and there's about a dozen of them if you go to NuGet. I started, guessing and grabbing. I got into this whole thing about data collectors versus report generators versus report runners versus in-unit stuff and that. And I got to somebody's GitHub talk about binary versus XML, and he said, run these lines. And I'm just like, no, I'm not going to go there. What else option do I have? Well, Visual Studio has had code coverage as part of their core product forever. But the code coverage feature is available only in Visual Studio Enterprise Edition, and I'm not about to pay $250 a month just to demo it. So take away what you will from that, but I just find this so amazingly frustrating that out of the box, I can't just get coverage working. And I'm going to put an offer out there. If anybody wants to pair with me or mob with us to try and get this working so I can add some more slides to the deck, ping me, because I would love to get this working, but it's one of those that if I had paired with the right person, it'd probably be working, but trying to figure it on your own, it's going to take you some time. So some other languages here. Python, I used PyTest and a pip install of coverage here, same 3 tests. It gave me effectively line coverage. I didn't see a way to turn on branch coverage for this. The reason that it was a little bit lower here is item is part of the gildedrose.py file, and it wasn't exercising whatever that is. I don't know Python well enough. Oh, and in Italy, we call them Babbo Natale, Father Christmas. JavaScript, this was actually one of the nice surprises, and probably one of the things that I'll keep in mind is that there is a coverage package you can get with NPM, and running just with that, you get branch coverage out of the box. It just reports it, and it shows you the uncovered line numbers, just as part of its reporting. So really nice artifact there. And honestly, the only one out of the languages we talked about that does branch reporting by default. So taking a stock of where we're at, Java and JavaScript, I could get branch coverage working. C#, I'm pretty sure it works. Python, I don't know if it does or not. So we're only at like a 75% branch coverage rate on the languages that I surveyed. And I don't even remember what this transition slide is about, but now it's coming back to me. So one of my bigger takeaways from all of this is that 100% isn't enough. It's just never going to be enough, and you can't go above 100%. You can't give 100%, 110% code coverage. That kind of leaves us with a quandary. Like, well, in that first case with 3 tests, I'm getting 100% reported. What do I do? And that's where this other thing comes in, this thing called mutation testing. This is something that was kind of like bubbling back in mind years ago. When I dug into it, it makes sense. I'm going to demo it a little bit here. I only showed it for Java. I'm sure there's tooling for other languages out there, but this is what you absolutely have to be doing if you're in a shop where you care about coverage percentages, because this will show you where the gaps are in your 100% code coverage. So the idea behind mutation testing is actually pretty simple. Just take that code that we're testing and make one small tweak to it. And that tweak is called a mutation, or it's called mutant code. When you make that one small tweak to the code, run all your tests against that code again. If the tests fail, you have detected the mutant and you have killed it. If the tests pass, that mutant has survived and your test coverage isn't sufficient. So that's really the heart of it there. I'm going to show a demo of this here in a second, but let's take a look at it just real quickly in the slides here. Here is with the 3 tests, one of the lines of code that was executed. This is probably for backstage pass. Yeah. So if item equals backstage pass, if the sell in is less than 11 and the quality is less than 50, because we have that cap of 50 in quality, then we increase the quality by 1. What the mutation testing does here is take this line 25 and generates a couple of mutants. It changes that less than 11 to less than or equal to 11, and it also flips the sign from less than to greater than. And it runs the test against this, it runs the test against that, and when I run it in PyTest, I actually get this. Changing the conditional boundary survived. My test, 100% branch coverage, don't detect this, but my tests do detect that. So even when I thought I had tested every behavior as best I could with 23 tests. Running the mutation coverage showed me, nope, still not good enough. There's actually a few tests missing for the behaviors documented in the system. So let's jump in and see that. Got another project here, Java mutations. I'll talk about why I did this at the end, but I basically have all the 23 tests, I think it is, just run them here, see it real quick. 23 tests, all passing. Trust me that the coverage is correct there. But now when I look at this test code, there's actually orient myself to that. There's a PyTest, pit test, all tests in the module. And when I do that, it takes a little bit of time, but for a small piece of code like this, it's actually not that bad. And it gives me some feedback. It actually generates a report that shows me for gilded rows, red indicates there is a missing test. And if I hover on this one, update quality, change the conditional boundary survived, negated conditional killed. Same thing down here, change conditional boundary survived. So I don't have like a less than or equal to 50 here. Same thing. So I can go through this and I can reason about how do I get the further cases. And you can see there's more reporting down here, more information about which mutators they're running. I don't know enough about mutation testing if this is common language or just exclusive to this tool, but these are the kind of things that the mutation testing is going to do to your code. And in fact, if I ran this against the 3-test version of the code, almost all the code is red because there is a lot of incidental coverage going on there. And so why do I think this is important? Again, I've showed you that with the best intentions, we can get into conditions where we've got coverage numbers that aren't exactly telling us the whole story. I've actually encountered these fake Santas out there where through malice or neglect, these things have happened in code bases that I've seen. Not only is there no Santa Claus, but there are things masquerading as Santa. There is a non-assertiveness Santa that I have come into code bases where somebody made a change to the code, breaks a test, and hey, comment out the test, comment out the assert, and the test still passes. This is going to give you the same exact coverage value, whether there's an assert or not. It's just exercising code. It's not varying quality or behavior. The remedy for this one, there are plugins. There's actually free plugins. SonarLint has one that will detect this and say, add at least one assertion to this test case. It will call this out and report this as a problem. This does require us to pay attention to it and adhere to it. If you've got a warning panel that has hundreds of warnings, you're not going to catch this. So in my code bases, try to treat warnings as errors and fix them or clean them up. There are ways to suppress them if there's something that you actually want to do, but this is something that you got to pay attention to. And most of the tooling isn't going to detect this. I've come into code bases where this has been, and it's like, now we got to figure out, is the test good? Is the test bad? Why is it failing? How did this even get here? Fake Santa, missing decorator. So Santa's got no clothes on. I do a exercise in some of my classes where we give demos of tests that look good but aren't right. And this is an example of one of those. I won't ask you all to tell me what's wrong with this test, but this isn't a unit test. It's got an arrange, act, and assert, but it's missing that decorator. So you could be writing unit tests, and if you're not paying attention, like here, I can now tell that, oh, this is grayed out because it's not actually called by anything. But if I'm not really paying attention, I'm not going to detect that I'm missing a unit test. The only ways that I've been able to figure out how to detect this and remedy it, I usually keep a mental count of where my tests are at and make sure that it's increasing. That if I think that I've written a new test, that number should go up by 1. If I think I've written 10 today, it should be up by 10. Also, coverage will not show this code. So if this update quality method is only called here, then you're not going to get any coverage for it. But if it's incidentally called by something else and you're writing behavioral coverage here and you forget that decorator, you're kind of out of luck. This one, anybody have a guess to which one has the higher coverage value? The case where 23 tests pass or the case where 23 tests fail? Well, the answer is it's the same. I mean, this is the same whether I comment out the assert or if I fail all the asserts. This is going to pass, or this is going to generate the same coverage metric for you. The remedy here, make sure your CI build should fail with one failing test. Pay attention to your failing tests. Enforce it at the developer level before it gets committed as a merge or a merged piece of code that will cause the build to fail. But on its own, if you have, and I was checking again last night, and inside of Azure, it's possible to have an Azure build that passes when tests fail. It's just a Boolean switch on one of the Gradle settings. So make sure that your build fails when you've got a failing test. And then the last one, I almost would never have guessed this could happen, but somebody contributed as an example in one of the code classes I was teaching. I don't think it was intentionally evil, but boy, it's evil. They actually overrode the assert equals as an empty method. And an assert equals with an empty method is always going to pass. My remedy for that, always make sure you see your test failing before you make it pass. See it fail for the right reason, then make it pass. And as a nice bonus, mutation testing will catch this, but guarantee most shops aren't doing mutation testing. Even in my advanced class, I only mention it. I don't really get into the details on it. It still feels like bleeding edge stuff there. Yeah, I think I know how this one came about, but when I saw it, I was like, wow, that's good. You really got me on that one. So kind of getting in the closing segment here, there's something called Goodhart's law. No talk is good without a law. Hey, that's another non-more law. When a measure becomes a target, it ceases to be a good measure. So if somebody tells me they want a coverage metric to target, I'm going to get them that metric. And I'm probably going to use some of the fake Santas, intentionally to get to that target. And I may unintentionally be doing things like incidental coverage to get there. And I've got a corollary for that. Code coverage isn't even a good measure. That with what I've shown you today, code coverage shouldn't even be talked about as a target. And I can't call that Moore's law because of Gordon Moore, but maybe Moore's corollary. We'll go there. And then just one of the last thoughts to leave you with, one of the code bases that I worked on where I was kind of paying attention to coverage metrics, but it wasn't really like a driving measure for us. I was working on a financial application where it was a financial system where we basically had one manager managing a lot of assets. And we did have some unit testing around this, but this was a legacy application that had been in production for a while, and I had joined the team fairly late in its development. So I was writing unit tests here and there with people, but by no means was this well unit tested. And then we got, the feature request. Rather than having one manager manage everything, what if we had a lot of managers managing small pieces of all of this? And all of our screens, all of our calculations were built on this model. And so what we did is we just started writing tests against this existing behavior, determined it was around 8% coverage for the entire code base. The entire code base was at 8%. And then we added this new feature, doing it in a test-driven manner. And once we got this out in a few months, we actually bumped up to 11%. So when people tell me like 80%, I'm like, good luck. We doing very deliberate practice bumped it up by 3%. If you wanted me to do another 60, 70 on top of that, we're going to just go quiet for a year and just be writing test code. And that is not a good use of the development team's time. So last piece here, I'm not knocking code coverage. Code coverage to me was like an eye opener when the tooling started to support it. I showed you can go into the IDE and see green, yellow, and red immediately. I'm not waiting for external reporting. I'm not waiting for HTML stuff. I can figure out and reason about what tests I need to add. Or, is it even needed? If it's a method that's not even called and nothing in my test suite is calling it, delete it, see what breaks. And I get immediate feedback on my test interaction with the code. And when I was thinking about the benefits for code coverage, this is about all I came up with. I didn't really go much further, but it does come down to that measuring coverage is like believing in Santa Claus. That just don't. I may have opened some eyes today. If you hear somebody talking about 80% coverage or 100% coverage, gently talk to them that it's not real, that there's ways to get better with what we're trying to achieve, but just measuring something isn't going to get you there. And so that is it. If you want to try it yourself, I've got the Python, JavaScript, C#, and 3 of the Java examples there out on the GitHub repo, Santa Claus of metrics. If somebody wants to help me figure out C# some more, give me a ping. I've got time here and there. I'd love to get into it. But again, this is me. Anybody talks about 100% code coverage, take me away. I am not part of that anymore. So thank you all for the time. I've seen some of the chat, but I haven't been really paying attention. But now I'll open it up for conversation and questions.
Yeah. Fantastic. Thank you. Thank you very much,
Thank
Paul.
you.
This is great. We will continue with Q&A. I know that there has been some chat in the text chat. George already has a question. Jay has a question. So I'll let go ahead and dive in. George, question.
More of a sharing. At one of the companies I was at, they had 100% code coverage. And when I started looking at the tests, I found out that they made sure that they went through every line of the code, but it literally had no conditions in it. And when I did find a few conditions, I found out that what they were fundamentally testing was the test library, not the actual code. So yeah, I mean, yeah, it was incredibly scary. So
been there, done that. And again, I think it's up to us to start spreading the word that, yeah, you can have this really on its surface, great looking number, but pull back the covers and what's really going on there. And, I, even in some of my research, I was finding like conversations around DoD specs where they get into some of that branching and conditional coverage, and it sounds really good. But if they're using this number to measure it, I don't know how real it is. Because I haven't found tooling that really gets beyond like branch coverage. It felt like there was something even more precise that not just branch, but like all permutations of the branches could be measured.
Yeah, thank you.
Awesome. Jay?
Hey, yeah, thanks for this talk. I really enjoyed it. You were talking about using the code coverage of tests as a way to evaluate tests. There's another context to think about code coverage that I actually think is really interesting, which is measuring in production.
Yeah.
So if you could measure code coverage in production over time, like there's all kinds of stuff you can do with that data. And a really obvious one is if we have code that is never executed in production, why does it even exist? Maybe it's dead code that's never called, or maybe it's a feature that people don't use, or could be many other reasons. But I think that that's like really interesting analysis to do based on production code coverage.
Yeah. And that's probably where I first encountered the topic, was deploying something and seeing what was happening in prod. And then, oh, by the way, now we can do it on our machines in the IDE to get that feedback there. But I would caution again that you could have that high coverage in prod, but it's like code that happens to be executed and it's not really valuable. It will identify that dead code for sure, but beyond that, I don't know if it's going to tell me anything I could actually do anything about, beyond like commenting out a lot of code and seeing what breaks. Does anybody complain? But yeah, I didn't include it, but you can for sure, when you turn on code coverage, it's basically taking the bytecode and adding some decoration around each line. And then every time it's run, it just like ticks up a counter what's going on under the hood there. So whether it's being executed by a test or by prod or by something else, you can get that coverage feedback. And I just focused on the unit testing side of it today.
Before reach top of the hour, I just wanted to quickly mention, we'll continue with Q&A. Next month, Scott Bain will be here on the fourth Thursday of the month, talking about commonality and variability analysis. So come back. And we'll go with that. Now to jump back in with Paul. Paul, it's funny with this code coverage. Obviously, as a fellow consultant, I've seen people use that and try to use that as a magic wand. And when I tell them that it can be gamed, I'm showing them the same things you are about how that metric can be gamed. And bringing Goddard's law into it, asking them, what is the behavior you're actually trying to change? What is it you're trying to do? And trying to change the conversation into, do you not trust your developers to be doing the right thing? Yada, yada, yada. And having a different discussion. It's like, why do you need that code coverage? What is it you're trying to do?
Yeah, and that goes back to when I first encountered the idea. It was like, well, if I have a higher code coverage, I have more confidence that everything is tested. And it really was kind of a jaw-dropping thing when I sat down with Cody and we wrote 3 tests for Gilded Rose and it was 100. I mean, it literally was like, oh, wait a second, what's going on here? And how I did it, and you can do it on your own code basis, I just took the last line in the code that wasn't covered and wrote a test for it. That generated about 40% coverage. I did it for the next one. It got me to about 70%. I did it for the next one and it got me to 100. And it's like 3 tests, 100% coverage, I'm done.
Yeah. Another interesting thing is, so, I do TDD. I practice TDD currently as my best development and thought process for writing code. What I've found test coverage to be helpful for is, and by TDD, it's true TDD. I am writing my test first, and that is then for that simplest thing possible to get it to pass. What I've found is that on teams that I've been on that are working that way, that there are even some times when some code does sneak in that is not test driven. It's this one quick little method did that. And running a code coverage tool can highlight some of those areas that where someone cut one corner to do one little thing. Hey, we can throw a test in there really quick. So my thing is, I use code coverage as a tool to help me investigate things.
Yeah, and I think low code coverage is a strong indicator of a lack of tests, but high code coverage is not an equally strong indicator of good coverage of tests.
That is a great way
that's the problem. And kind of like you know, when I do TDD, if I've done TDD and I've got confidence in the number, I trust it. But most systems, that code gets out of my hands and it could change, and all of a sudden I don't know what that number means.
Yep. Go ahead, Michael.
I've heard one of the red-green refactor things is, write a failing test and then write only enough code to make this pass. So that, there's I don't have the other clauses there, but that's a proof for you only generate 100% coverable code, because you wouldn't write code that doesn't help pass that test. Comments? Thoughts?
Well, so I've been in that, and there is a wide range of how people define what is the minimum amount to get that test to pass. Some people take it as carte blanche to say, I've written the test, I can write all the feature now. That is not the case. And especially for folks like me, Cody, and a few others that are here that follow that very rigidly, it's the smallest, dumbest thing possible to get that to pass. And then you go into refactor.
And that is a learned behavior that I was fortunate enough to sit down with the XP folks and pick up from them. And that's a lot of what I do when I'm teaching developers TDD from scratch. It's like, write a test and you know what the algorithm is going to look like, but what is the simplest code that's going to pass your test? Stepping that chasm between, I'm just going to write my code and I need to satisfy the test, is one of the bigger hurdles, I think, to adopting TDD.
And to really break down the simplest possible, the first test is return what am I expecting? So if it's a Boolean function that I'm testing, all right, return true.
Return true. Return
That's
0. Whatever.
You're done. It could be, well, your test frame harness could fail if new lines are introduced that aren't covered.
But with incidental coverage, how do you know? You'd have to do mutation testing at the same time. And mutation testing is just not quite fast enough to do it as part of my TDD cycle.
Yeah.
Thanks.
Awesome.
Steve, I see a few hands up still.
Yeah, Josane, I'm sorry if I'm mispronouncing your name. Oh,
sorry, I'm not using Zoom a lot. I was struggling to unmute. Yeah, just to answer to the fact that if you do small increments, you're supposed to end up with a 100% coverage test. I think it's pretty easy to slightly over-engineer during the refactor part. And you don't necessarily realize if you introduce something that is not covered at this moment.
Yes.
Yeah. Yeah. And that's where if you've got the mutation tooling in place, doing it as part of an integration build or a nightly build will at least start to give you some of that feedback. But if you were to do it on a code base that it hasn't been applied to, you're probably going to get way too much. It's like when you turn on a linter for the first time. So I would recommend with teams, just focus on what code are we touching today. Let's start there and then just ignore what's going on around it.
One of the tools that I've found that helps me to not go beyond and introduce new behavior for when I'm doing TDD is triangulation. Once I get two instances of the same thing returning, as Cody was saying, my test returning true, then I can refactor and I'm less likely to introduce new behavior using that refactoring of those two triangulated points, those two orienteering points. Yeah, it's an interesting thing. Rahul?
Thanks. So as we said, if low code coverage is there, then it definitely indicates that there is not enough test. Now, for a system where there is already a lot of code and there is low code coverage, then what would be the recommendation? I mean, because definitely we'll add some test, but as the coverage goes up, where do you strike the balance so that actually you have the right confidence and not a false confidence on the code?
Yeah, well, it goes back to that system I mentioned where we were doing financial calculations. We knew that we were about to touch a core calculation engine. So we wrote tests for the existing behavior because that still had to work after the new behavior was added. But then we, in addition, added unit tests to the new behavior at the same time. So that's where we bumped from that 8% to 11. But that was in direct response to new features being brought into the system. We absolutely did not, just sit around and go, hey, there's no coverage over there. Let's go write some tests. We left those dark corners of the code alone. I'm thinking a little bit, Michael Feathers does some work like figuring out hotspots in the code, like either methods that change all the time or classes that change all the time. Focus your efforts there, figure out ways to tease out behavior from that, get the coverage strong there, because those are the places that the team's touching already. But in my case, I was fine with 11% coverage. When I left that team, it was 11%, and that was a win for me.
I love that. One of the things that I couple with Fowler and finding hotspots is the strangler pattern. So what you're doing is you're finding those hotspots and you're starting to create these islands of trust that you have with code tests, with unit test coverage, and then eventually you can connect them if needed. It depends on the value. Right now, the software, most places, if they have low test coverage and they've got working software, the software is providing value. So how can you limit the amount of time that you spend refactoring things, so sometimes even just to make things testable and introduce tests without interrupting things? Because tests really don't provide that much value. They provide trust, and over time they provide value, but not direct value, not like the running software. So the strangler pattern, finding hotspots. The other thing that I've found works really well for legacy code bases with low test coverage is a philosophy by a friend that I heard from a friend named John Bull, that is find a bug, write a test. So at least you know that you will have less regressions moving forward to for bugs that are introduced into the system and fixed.
Yeah, Rahul, I haven't read this article, but it references Feather's work that I was thinking about, that they plotted their commits, like the complexity, whatever measure of complexity they're using versus how many times the file is touched. And they decided these things that are changing a lot and are also fairly complex are where they need to be focusing their efforts to either add testing or reduce complexity and refactor it out. But the stuff down here that's not changing ever and it's not complex, like data objects or whatever, don't even worry about those.
You can also apply the selfish philosophy of, I'm in this part of the code base all the time. This is where I work. I'm going to tidy up my little work area.
Yeah.
Yeah. Hossein?
I think there's also
tidy.
some times where some situation where you have a very high complexity in some part of the code base that you have to touch all the time, like very poorly written code, like spaghetti stuff. And you do have this lack of trust in changes you can do. And I understand in this kind of case, that it will not be enough to really go on by testing new stuff that you introduce with stronger pattern, because you have a large part of your code base that is at risk at every single deployment. And what I find help in this kind of situation is to write acceptance or end-to-end test for the main user path, like those 4 or 5 few things that really do bring most of the value of the system. Write end-to-end test for that. And even though you're still far from being very confident in everything you can do, at least you know that you will not cause a disaster if you go in production without writing tests for everything.
Yeah, and I think Featherston is working effectively with Legacy Codebook, talks about scenes, where can I start injecting newer, better behavior that I can test completely in isolation, and it just happens to be called by that complex area. So that's another way that I've dealt with that situation.
Interesting that you just mentioned themes after Steve mentioning the hotspots. It's kind of get the edge, get the center. It's kind of a neat.
Yeah, and I feel that a lot of this stuff is like things we've learned along the way, but it's not taught everywhere. And so much of development is just like who you happen to bump into and learn from. And, I was absolutely happy to record this because I just want this to be more evidence that code coverage numbers are BS.
Well, and that's why we're here.
Yep.
That is exactly why we, the Seattle Code Crafters, are here.
Yeah.
Because
we into more people.
What?
Yeah, bumping into more people. Hello from New York.
More people.
Yeah, Michigan last week.
For example, I didn't know what mutation testing, what name mutation testing was. Maybe like a year ago, I heard that name, but I always knew, like, I've saw fishy tests before, and I'm just like, oh, you care about this production line of code? Oh, what if I delete it? And then run the test. Oh, they all pass. Oh, so you don't want this test? Let me get pushed. They're like, no. Yeah. So I totally agree. Having a community like this, it's easier to share those names, those ideas.
Yeah. And I think so much of our time is spent solving the problem in front of us that we don't have the time to go out and research these things. Because I guarantee there's probably 10, 50, 100 papers on the same exact talk. But, unless it comes across your desk and it's like staring you in the face, or we make the effort to come to an event like this, you're just not going to hear about it.
Hossein, do you have a question, or is your hand just still up?
No, I actually really upped it. Yes, there's one thing that we haven't really mentioned. Like one point I'm struggling the most with the problem of high mutation testing is when you have a colleague, for example, that is very confident in the tests they produce, in all the code they send, that it does detect any kind of problem, but once you have to really get in and change some major feature around, you realize that it's absolutely impossible to work with it, because the smallest refactoring will break 90% of the test in there. And I don't know, like, do you have any method, to detect this before and prevent this situation from emerging?
Well, that gets into the separation of testing behavior versus implementation. that the tests that I've written for Gilded Rose just care about the outcomes. They don't really care that it's an if statement or whatever. So I could wipe out that whole implementation and then put in something much simpler, and the tests are still going to pass. So, depending on your domain and what's going on there, I would start looking at like the actual outcomes of the system as opposed to more of the details. And when you talk about like integration tests, you're almost always going to be getting into some details. And that's why I tend to shy away from like mock objects or test doubles, is that a lot of times it's like, did I call this thing? Yes, you called that thing. And if I change that, now I've got a reason about why the test failed.
Yeah, that's 100% the problem we had there. Everything was completely mocked, and
Yeah.
it's difficult even to, like track this kind of thing unless you do a systematic review of everything, and sometimes you
Yeah.
cannot oversee personally all this kind of code. So
Mhm.
if there was any kind of method or tooling, that help
Yeah.
detect it, that can save a lot of time.
Yep.
And some of it comes along with, the age and the experience, but also the humility. I have learned so much. It's like I implement things my way, but it's not the only way. And I'm more than happy to learn from somebody fresh out of school, even because they're more up to date on most everything than I am.
Yep. So I don't know of any tests that would help with tightly coupled code. However, there are other metrics out there. Again, all metrics are bad, but some metrics have use. They're good at highlighting smells. And so cyclomatic complexity, cognitive complexity are both two metrics that can tell you can give you insights into how fragile code might be. And there are ways to build things in to build systems that will throw flags. Again, I'm against that, but there are ways to do that if you so choose. But again, any metric can be gamed. And when someone asks me to put gates in place around metrics, I'm saying, what's the behavior you're trying to change?
That actually hits why I raised my hand, because I met a guy actually at the Lean Coffee table there in Seattle who had left Seattle, but had a group that he tried to figure out a metric, and they kind of gamed it. And then he had another metric, and they kind of gamed it. And then there was a third metric, and they kind of gamed it. And he backed up and said, they are going to game it. Make sure you set up the game that you want.
Oh yeah.
And it turned out that he played around with 1 wasn't good enough, 4 was too much. These 3 were right. And he said, unless they're trying to be evil, if they hit this number, I get the behavior I want. But he had to play around with which numbers he was measuring to game it to get what he wanted.
Right. Well,
and then you had to assume that they weren't evil.
Yeah.
Right.
And that's where the DORA metrics came into play. Right. Okay, sure. If you're going to game metrics, game these metrics, because we're going to be getting the right thing over time. Here's the thing is the people that you're working with. So we're talking software developers here. We are talking people that during COVID had a whole bunch of time, decided to figure out OBS, put green screens on my back pictures here. So now I can put all these neat little pictures here. I'm looking at you, Gray. Developers, if they have a lot of time or motivation, they're great at solving puzzles and gaming things. So you're giving them a metric they're going to game.
Yeah. Absolutely. I can't say that I've ever seen evil intent. It's usually been an incentive to what's the easiest way I can get this goal that's been put in front of me.
Yeah, I'm more likely to do it to get a little hit of dopamine. Like, yay, game. I win. I win. That's what sucks me in the TDD. I can win rapidly instead of every quarter or every year.
I've seen as code coverage is a metric, not percent. Yeah, percent code coverage as a metric be gamed. One guy was just adding tests into the system. So the number of tests in the system overall, the number was increasing.
Yeah. And that's where I showed in IntelliJ, you can see the number of hits of a line of code. It's like 20 seems like a lot, but that to me is more like a design smell. It's like, why is it doing it there for everything? This probably should be somewhere else tested in isolation.
Right. So, it again, if you're going to challenge a developer to a game, they're going to game it and give them all day to game it.
But just make sure you're playing games you want to win.
Yeah.
Right.
But as we've seen, without complete understanding of the playing field, you may not even know some of the rules that are at play here.
Yep.
And you'll never see the whole playing field. So
yeah, that's like I'm on the edge of wondering, is mutation testing enough? Maybe it's not, but I don't know that anybody's really pushed beyond that in the things that I've come across.
Mm-hmm.
In the absence of any kind of metrics, I think the only thing that can actually push further for mutation testing, is only the practices, because mutation testing won't actually be ever able to see if you can refactor your test without breaking it. I don't see any true way, of automatizing this.
but to Jay's point about like testing in production, when there's chaos monkey, which is kind of tests at a different level, can you recover from something that we probably didn't think about?
Mm-hmm.
And they've got other kinds of monkeys other than the chaos monkey that I've heard about.
Yeah. Well, I fall back on what is the behavior that you're trying to get. Because if you're talking about even any of the code metrics we're talking about here, what is the problem we're trying to solve with this?
Yeah.
Does our software work? Well, is there a different way to determine if our software works or not? What's the simplest way to do that? For coming in and, trusting your developers to be doing the right things, there are other trailing metrics that you can do. But again, it's why are we in this in the first place?
And I think that's the heart of this problem, is that we want to have confidence in what we're building. We want to measure it somehow. We want to maybe not spend so much on QA resources. Well, code coverage metrics. And, nobody, I would say nobody non-technical is going to even appreciate what we're talking about. And most developers don't even appreciate what I was talking about.
Yeah.
Until you reveal that there's no Santa Claus.
Right. Well, or you realize, okay, the code, let's say it is well covered, but now it's just a ball of mud or a pile of spaghetti under the covers. So now then we need another metric that we have to watch.
Yeah.
And so as someone who's worked on both sides of the divide, the development and the business side, when I was in as a manager, I was writing code in an ensemble with the developers. I knew the state of the health of the code because I would sit in on the ensemble. I knew what was there.
And what metric did you use to know the state of health?
By writing code, by writing code with them and actually seeing how hard it was to add new features and bugs coming in, things like that. It's very easy for a developer to dive in an ensemble and know that the health of the code base.
And you have that ability to sit with them and understand it, which is not most people.
Which is not most managers.
Yeah.
They want to look at metrics, or some folks just want to look at metrics, and that's
the
heart of it. It's a trailing metric. Go sit down, build a relationship with your developer. I mean, it's a lack of trust is really what we're talking about here. In some places, like we're using code coverage because we don't trust that things were properly tested, or the automated tests aren't enough.
Well, and again, I don't know that I would go to the level of attributing malice. It's just like, I want to know more about the system, and here's a cheap and easy way to do it that just doesn't happen to work. Right?
Yeah.
Because I'm kind of being facetious, but I have had that non-technical manager come in and just demand something that's like, oh, okay, let's give them the number.
Well, so the business world has a solution for things about financial accountability for companies. There are third-party auditors that come in that are regulated, that come in and do audits and can give you a yearly report on the health of your finances. For that, it's a bit more stringent. But there have been times when I've been asked to come in and give a state of the health, come in, audit our system, audit our process. How healthy is the code base and how healthy are our development practices?
And how do you answer that? They can absorb.
A lot of times I'm going in, I'm taking a look at the code base. I'm doing the same thing I just explained I do as a manager, is I come in and I write code with the teams. I see how hard it is for them to do things. I talk to them. I get a feel for defect counts, how hard they are, the big ones, the defects that are difficult to fix. Then I go and look at the code base in that specific area and other places. I'm running different types of metrics from cyclomatic and cognitive complexity, and then looking at code bases and just perusing the code.
And then your summary looks like what?
It's a report that I share with teams and executives. Also dependency graphs, dependency trees are helpful too for that.
It's probably a mix of qualitative and quantitative, right?
Yep.
And I was barking at the fact that you put numbers in that, but it's not enough.
There is data. However, there's gray opinions mixed in with it.
That are true and reasonable and helpful.
Trying to be. And sometimes I come in and I say, Cody needs a raise and you cannot stand to lose him. Because he's the linchpin for the whole project. If he goes, everything's going to fall apart for at least 9 months. I've been there and I've said that to companies.
Metrics can't tell you that sometimes.
Yeah.
Yeah.
And then I say, if you want to avoid that, what you're going to have to do is actually tell Cody to go on a 3-week vacation.
See what breaks.
Pay for it. You've won a 3-week all expense paid vacation. Go away, Cody.
And don't call him during the vacation.
And don't call him to Antarctica where they don't have cell coverage.
Uh-huh.
And voila, now the team has to struggle and find out how to work in a small chunk, and they get better.
And Steve, that's almost what Chris Lucian is calling chaos HR, where he tells key people to call in sick or not show up to work for a day and see how it goes.
Yeah. Yep. All right.
I'm a bit sidetracking on this, but I have a question actually when you say that. Is it that difficult in most American company to take 3 weeks off and not having everything collapse around you?
Absolutely. Whoever's left, who has left a job and had like more than 8 weeks of banked vacation that they just never used? I mean, I for sure, and you don't generally get that much vacation to begin with. I'm thinking of companies where I would get 2 weeks a year and I left with 6 or 8 weeks that I hadn't used because you're just always overwhelmed with stuff that needs to be taken care of and you're the only one that knows how to do it.
So one of the things that's really hard for US developers to do is to take a vacation and not take their laptop with them. I know many developers that when they go on vacation, they work probably 20 to 25% of it. This is why I really encourage people on teams that I'm with and that I'm working on. When you're on vacation, go away. When I leave work, my phone right here gets put like right there on that bed, and I go up and I'm present with my family. But that is a rarity, unfortunately.
Yeah. And I mean, to be honest, that's mostly why I left the general workforce a few years back, is because it's just so broken to me. And I couldn't figure out how to make it work other than to do what I want to do for myself.
Mhm.
Thank you for your answer. I'm asking because I'm currently in France and thinking of maybe starting to work somehow with the US, but it feels like there is not a very large ecosystem of crafters. And I feel like these are symptoms, that if teams struggle so much and have single points of failures, that there is something going on that is pretty wrong with the software ecosystem.
Yeah. And to be honest, where I'm at today, I would rather work with a good group of people over anything else. Domain, language, tooling, location, whatever. If they're people that I get along with and going to learn from, that's my biggest criteria.
That is a powerful statement. And what I've met, both of you make powerful statements. What I've observed is that crafters tend to be the top 1 to 2% of the development population. They are willing to work with teams of crafters and take pay cuts to do that.
Yeah, I actually took a pay cut to get at my current job just because I was tired of producing so poorly written code and not being able even, being given the permission to write something decent.
Yeah.
Yep. Yeah. Todd, would you work for $20,000 less to work on a crafter team? Yeah.
Yep.
Yeah. No, it's crazy. And that's one of the, just so you know, Industrial Logic does have a European presence, and we do look for crafters in Europe. So keep an eye open for that. Also, at times in India as well, too.
Okay. Thank you for the information.
All right. Well, we are half past the hour, 90 minutes in. I'd like to go ahead and wrap this up. So, Paul, thank you. Thank you very much.
Yes,
thank you very much, my friend.
Thanks for the
Good
kick in the
talk.
butt to get it together finally. Nothing like having a date on a calendar to force action.
Yep.
Yeah. And Christmas is coming in a certain amount of days, period. No pushing that deadline.
Oh, yeah.
Nice.
Yep.
Yeah,
All right.
thanks.
And next month, Scott Bain talking commonality, variability. November, I'm going to be talking about small. What's the next simple, or not small? What's the next simplest thing? It's going to be a simple thing that's very interesting to talk about. Anyway, everyone be safe, have fun, and we'll talk to you guys. Hopefully see you more soon.
All right. Thanks again, Steve.
Thank you very much. Have a good day.
Bye.